with many large system builders in the aerospace, defense, automotive, medical device communities, and we see many exciting things that were being built today in terms of autonomous vehicles, medical monitors that are connected to cell phones, iPhones for alerts and status or sharing information with loved ones and our doctors, and then even the simple things in life like mortgage and gas pumps or banking machines. And while these solutions that they build are all unique by their nature, they face many common challenges in terms of increasing complexity, shortening cycle times, risk of meeting customer market needs, product variation and variability that's being demanded by consumers. Their solutions also span many organizational boundaries in terms of supply chains and system of systems. Even some of these smaller systems that get built, there's always a supply chain involved. And on top of all this complexity, we still have the contractual and regulatory compliance demands that are faced by these systems, especially in life-critical ones. The old system, the old way that we've worked in, where we specify everything up front in as much detail as possible, and then hand off these detailed specifications to teams who work in relative isolation with some aligned integration points that are way downstream, they don't address these challenges. They don't provide the early feedback and the early decision-making that we need to make these large complex systems. These systems by their nature have large degrees of uncertainty and unknowns, and we're asking our system builders to be innovative in the way they create these systems. We need to put them and offer them an organizational system that emphasizes learning and knowledge creation in addition to building the system. And we need everyone aligned on a common solution. We simply just need a better way to work.
Agile has long become a de facto industry standard for software teams, but in case of hardware, we're running into the same brick wall over and over again. It's interesting that practitioners in the field often refer to the same reason over and over again why they cannot apply Agile to hardware development. And that reason is we cannot produce working hardware as frequently as software teams can produce working software. And they're right. But what's interesting about it is when we look back into software agility, we realize that there's a reason why we do want to produce frequent increments of value end to end. And that reason is not because of increments themselves. We're looking for accelerated learning. We'd like to run those plan, do, check, adjust cycles very frequently. And for that, in case of software, it's very easy to do by producing working software increments. Now, in case of hardware, it's not possible, at least not at that rate, and it unfortunately prevents us from being agile. Well, that's a big mistake. What we should do is go back to the very foundation of being iterative and incremental, and that's to be able to execute that fast learning cycle. Let's ask another question. Can we learn fast in case of hardware too? Maybe without fully integrating the system every 2 weeks, but maybe there's something else we could do. And indeed, one of the techniques is to control the depth of integration. Instead of integrating every component end to end in a large solution, what we're trying to do essentially is to be selective. Some of the components will be real components, some of them will be substituted with their cyber-physical approximations, others will have software proxies, and some of them will be just stubs. Well, that will allow us to minimize the cost of integration so that it would be doable at much more frequent rate without really losing much in terms of feedback. And that's just one of the great techniques.
A regular common cadence is that vehicle we use to create those plan, do, check, adjust learning cycles. We're not a bunch of separate, independent teams that are focused on our part of the solution in isolation. Instead, we're an aligned team of teams or large program value stream, aligned and focused on creating near-term business value, and then also learning about what will be the ultimate solution. We use cadence to regularly align all those folks, align everyone, and have them focus on a small set of near-term goals, near-term objectives. Cadence also allows us to see some form of the solution regularly at each one of those cadence boundaries, with perhaps some lower fidelity approximation for some of the components. But we can still assess that solution for feedback, that we're indeed on track to not only build that right solution, but also meet any compliance demands that we're going to have at the end. Cadence also reduced our variability. By focusing on regular incremental objectives that give us feedback, we can then make adjustments. We can make adjustments to ensure that we make the long-term deliveries more predictable.
Well, one thing to understand is that cadence is not just a time box. There's a lot more to that. There are certain events attached to that cadence. So when we say that a program operates on the cadence, it means that they plan together, execute synchronously, and review the results together. And repeat until further notice. This is really critical. When we say everyone plans together, they all plan together, it begs the question, who is everyone? And that's a really important question from the organizational design standpoint. We often make this mistake by organizing teams and groups of teams around, let's say, part of the architecture or part of the engineering discipline or a function. That's a big mistake because oftentimes we start seeing how tightly coupled those different groups are, and it just doesn't help. It slows us down. Well, in fact, sometimes we would rather organize completely differently, completely orthogonal to that. One of the examples could be as follows. Look at these two teams. One of them is firmware team, another one is hardware team. It's not uncommon that such teams have a lot of hard dependencies on each other. So now, instead of having too many handoffs across these two groups of people, we'd rather have two teams, each one having some firmware and some hardware folks on board, and each such group would be organized around end-to-end solution capabilities instead. In this case, there will be lesser handoffs across teams because most of them would be encapsulated on board each team, which means that each team would have a much higher velocity and the organization as a whole would be much faster, would have much higher throughput of value.
Related to team organization is just in general, how do we organize around value delivery? Value streams organize people to continuously deliver value in the shortest sustainable lead time. Therefore, we need everyone on the value stream to be able to ensure fast, reliable delivery. So therefore, the value stream is really going to extend across the whole solution to all stakeholders involved. We show a couple examples here of those participants, including suppliers and customers. We expect everyone on the value stream so that we can build, integrate, and learn together. We need customers to actively participate in setting priorities and validating our incremental solutions. And while suppliers may not internally follow a lean agile process, we do expect them to participate in those plan, do, check, act ceremonies because we need them to learn with us about what the ultimate solution will be.
For more information on adding hardware to the mix for the large Agile enterprise, see321gang.com and our Lean Agile webcast.